All right. Looking at the first 8 problems. On the first 8 problems, you notice like number 1 has f divided by g of 16. And then if you look down to number 3, it's f divided by g of x. So we're going to look at number 3 first. It is f divided by g of x. And looking at your test, if you look at the function f, well, first of all, let's write this down. We have f of x divided by g of x. So looking at those functions, f of x is x to the 5 over 4. And g of x is 2x to the 1/2. What do you do with your powers whenever you have it set up like this? You subtract them. Now, there's also an understood 1 right there. So 1 divided by 2 is just 1/2. And then if I'm subtracting my exponents, I have x to the 5 over 4 minus 1 over 2. I know you don't have a calculator right now, but if we were to go ahead and subtract those, I would get 1/2 x to the 3 over 4. And that is my f divided by g of x. So that's your answer for number 3. I don't like that. All right. Then if we go back and look at number 1, number 1 is f divided by g of 16. Well, all I have to do is take this right here and plug in my 16. So I have 1/2 times 16 to the 3 over 4. So if I put that in my calculator, hang on. All right, if I put that in my calculator, I know you can only see part of that, sorry, but it was 1 divided by 2 times 16 to the 3/4. I get 4. So now I have f divided by g of 16 equals 4. Okay? So there's 1 and 3 done. All 8 of these have pairs, so really you only have to work out 4 problems and then plug in 4 numbers. So now let's move on. Looking at number 2, number 2 is f minus h. Which one pairs with number 2? Number 8. So number 8 is f minus h of x, which means I'm going to have f of x minus h of x. F of x is the x to the 5/4 minus h of x is 3.7 times the 4th root of x to the 5th. Those don't look the same, do they? But can I change it so that it does? How could I rewrite the 4th root of x to the 5th using fractional exponents? Yep. So I have this is equal to x to the 5 over 4 minus 3.7 x to the exponent is 5, it goes on the top, the radical is 4, it goes on the bottom. So now with an understood 1 in front, 1 minus 3.7 is negative 2.7 x to the 5 over 4. And that's my function, f minus h of x. So now, that paired with number 2, all I have to do with number 2 is plug it in. So if I have f minus h of 81, then I just plug the 81 in. Negative 2.7 times 81 to the 5 over 4. So here we go. Negative 2.7 times 81 raised to the 5 over 4. Negative 656.1. So negative 656.1 is my f minus h to the of 81. Okay, so there's 4 done. We've done 1, 2, 3. Number 4 is f plus h. Which one pairs with number 4? Number 6. So I've got number 6, f plus h of x, f of x plus h of x. So basically the same two functions we just wrote down. F of x is x to the 5 over 4. H of x is 3.7 times the 4th root of x to the 5th. Change it just like we did before. Bless you. So I have x to the 5 over 4 plus 3.7 x to the 5 over 4, which gives me what? The understood one right there, so that gives me 4.7 times x to the 5 over 4. And that's my f plus h of x. So pair that with that number 4, because that's my answer right there. Number 4 says f plus h of 16. So I'm just plugging 16 in. 4.7 times 16 to the 5 over 4. So we have 4.7 times 16 to the 5 over 4. 150.4. So there's my f plus h of 16. Okay? We good with that so far? Last set. We've done 4. Let's go to 5. 5 is f times g, and it pairs with which one? 7. So I have f times g of x, which is just going to be my f of x times my g of x. F of x is x to the 5 over 4. G of x is 2x to the 1/2. When you're multiplying bases, what do you do with your exponents? Add them. So first, let's look at coefficients. 1 times 2 is 2, and then add the exponents here. So I have x to the 5 over 4 plus 1 over 2. Again, I know you don't have a calculator, but this is going to give me 2x to the 7 over 4. So you would just put in 5/4 plus 1/2. So there's my function. And plug it in. So number 5, f times g of 1. So I've got 2 times 1 to the 7/4. Any 1 to any power is what? 1. And 1 times 2 is 2. So f times g of 1 is 2. All right, so number 1, the second number 1. And just fair warning, number 1 here is probably the longest problem on the whole test. So bear with me. It says solve and check your solutions. So we have the square root of 5x minus 9 minus 1 equals the square root of 2x minus 1. When we have square roots like that, what do we do first? Square both sides. On the right side, the square root and the square will cancel because that's all that's there. On the left side, I have a -1 outside of it, so those can't cancel. I've got to go over to the side and box that. So I have the square root of 5x minus 9 minus 1 times the square root of 5x minus 9 minus 1. So when I multiply the square root of 5x minus 9 times the square root of 5x minus 9, what do I get? The square root of 5x minus 9 squared, right? So it would just be 5x minus 9 because the square and the square root cancel. Right here, negative times that square root is just the negative square root of 5x minus 9. And the same thing right here, negative square root of 5x minus 9. Negative 1 times negative 1, positive 1. So let's take all of this and write it with our problem. We have 5x minus 9 minus 2 times the square root of 5x minus 9 because I have two of them that are the same. Then a plus 1 equals 2x minus 1. Combine your like terms. I have a minus 9 here and a plus 1 here. What does that give me? So then I have 5x minus 8 minus 2 square roots of 5x minus 9 equals 2x minus 1. What now? I can't get rid of the square root sign until it's by itself. So we need to move everything else away. To do that, we're going to subtract 5x and add 8 to both sides. On the left side, when I do that, they cancel out and leave me with negative 2 square root of 5x minus 9. On the right side, 2x minus 5x is negative 3x, and then plus 7. Now, what do I do? Divide by your negative 2 on everything, because that radical is not by itself yet. So divide by negative 2, and I get the square root of 5x minus 9 equals positive 3 over 2x minus 7 over 2. Now you can square it because that radical is by itself now. So square both sides. On the left side, the square root and the square cancel, and I get 5x minus 9 equals, the right side, what do you have to do? How do you square it? You have to box it. 3 over 2x minus 7 over 2, and then 3 over 2x minus 7 over 2. You have to box those. You cannot just distribute that square. A lot of you have made that same mistake. All right, so 3 over 2x times 3 over 2x. What does that give me? 9 over 4 x squared. Very good. 3 over 2x times negative 7 over 2. Very good. Negative 21 over 4. And same thing here. And, oh yes, there is an x. I'm sorry. Thank you. Last box. 7 times 7? 49 over 4. Negative times negative is positive. So then that all goes over here. 9 over 4 x squared minus 42 over 4x, because I'm combining the 21s, plus 49 over 4. How many of you would love to deal with all of those fractions? Not this girl either. So I am going to multiply the whole thing by what? 4 because of the denominator, the common denominator on the right side. Doing that, I have 4 times 5, which is 20x. 4 times negative 9, which is negative 36. On the right side, the 4 cancels with all of those on the bottom. So I'm left with 9x squared minus 42x plus 49. Now what? Move everything to the right. So 20x, I'm going to subtract. 36, I'm going to add. So subtract 20x, add 36. On the left, they cancel. And 0 equals 9x squared minus 62x plus 85. You want to use P and S? I don't. The reason I say that I don't is because 9 times 85 and then the factors of that to add to get negative 62, that doesn't sound nice at all. Okay. Let's use quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, could you use P and S? Absolutely. You sure can. You can do whatever you want to do with that. Factor it however you want to. But personally, I think this is easier because there's a lot less thinking involved if you remember that. So 9 is my A, negative 62 is my B, 85 is my C. So plug everything in. X equals negative, and B is negative 62, plus or minus the square root of B squared, so negative 62 squared, minus 4 times A, which is 9, times C, which is 85. So we're not simplifying anything yet, we're just writing it all in. All over 2 times A, which is 9. Sir? I know. It's long. All right, so X equals negative times negative, we said was positive 62, right? Plus or minus the square root of. If I put all of that right there in the calculator, trust me on this, you're going to get 784. All over 18. Do you want to see it in the calculator? Okay. All I did was put the discriminant part in the calculator, what's underneath the square root. And lucky for us, it comes out to a perfect square, and put that in your calculator, and you're going to get 62. I'm going to go ahead and split it here. 62 plus 28 over 18. And then X equals 62 minus 28 over 18. So the square root of 784 was your 28. And instead of writing it all twice, I went ahead and did the plus and the minus. So 62 plus 28 is 90 over 18, and that is 5. 62 minus 28 is 34 over 18, and that is 17 over 9. Look at your test. You have 7 over 3, negative 7 over 3, 5, and negative 5. This says to check your answers, but even checking on the multiple choice, that one's not an option. 5 is my only other option. So you kind of get off easy on the check part, which is nice since the rest of the problem was so long. Okay? We good on that one? I know it's long, but that's the longest problem of the whole test. All right. Number 2. X plus 90 to the 1/2 equals X. What do I do? How do I get rid of that 1/2 power? Nope. I want to get rid of the 1/2 power. Raised to a power of 2. So I have to do that to both sides. On the left side, they cancel. And I get X plus 90 equals X squared. Now what? Nope. I just squared both sides right here.
You gotta take the 90 away from.
Move everything to the right. Subtract X, subtract 90. Subtract X, subtract 90. So I'm trying to solve it. So that's going to cancel. And I have 0 equals x squared minus x minus 90. Now what? Product sum. Multiply to get negative 90, add to get negative 1. What are two numbers close together that multiply to get 90?
91.
Close together. 9 and 10. So 9 times 10 is positive 90. One of them needs to be negative which one? Okay, so if I have negative 9 times 10, I have negative 9 plus 10 over here. That's positive 1. I need negative 1. So then 9 times negative 10 would give me 9 minus 10, which is my negative 1 that I need. So let's write those factors over here. 0 equals x plus 9 times x minus 10. What do you do? Good. Set them equal to 0. X plus 9 equals 0. X minus 10 equals 0. Subtract 9 on the left side. And x equals negative 9. Over here, add 10. And x equals 10. You have to check them. These will be a pretty quick check. If I'm looking up here, x plus 90 to the 1/2 equals x, start with your 9. Negative 9 plus 90 to the 1/2 equals negative 9. What's negative 9 plus 90? That's 81. What's 81 to the 1/2? 1/2 power is the same as taking the square root. The square root of 81 is positive 9. The right side is negative 9. Does positive 9 equal negative 9? Nope. So that one's not an answer. Which only leaves you with 10. And that's an answer choice. It's F. Okay? Turn the page. All right, number 3. We have 4x to the 3 over 5 equals 32. What do we do? What do we do? Very good. Divide by 4 on both sides. Dividing by 4, I get x to the 3/5 equals, what's 32 divided by 4? 8. Now what? How do I get rid of a 3/5 power? 5, what? 5 over 3. So, I'm going to raise, not multiply necessarily, but raise both sides to a power of 5 over 3, which makes my powers multiply. And the left side, they cancel. I get x equals 8 to the 5 over 3, which is 32. Now, the question on this is, okay, well, that's 32. Should it be plus or minus 32? Well, if you look at the bottom of the fraction on the exponent, it's a 3. If it were 1/2, that's the same thing as square root. 1/3 is the same thing as cube root. So if that's an odd, you don't need plus or minus. If it was an even number on the denominator, you would need plus or minus. But this one we don't. If it was 5 over 4, it would be plus or minus. And then you would have to check the positive and the negative. This one does say check, but that's your only answer. There's not a no solution there. So our answer is B. All right, then let's look at number 4. Number 4, we have the cube root of x cubed plus 27 equals x plus 3. What do I do first? I can't move everything over yet. There you go. Very good. Cube both sides. cube's a little funny, sorry. So my cube root and my cube cancel. And I have x cubed plus 27 equals, what do I do with this?
8 squared.
Nope.
Put it in a box.
Put it in the box. You have to box it. You cannot say 8 cubed plus 27. That does not work that way. So I have x plus 3 times x plus 3. X squared, 3x, and 9. Then I have to take that combined, so x squared, 3x and 3x gives me 6x plus 9, and I have a third x plus 3. Put it in the box again. So x times x squared, x cubed, x times 6x, x times 9. X squared times 3, 3 times 6x, 3 times 9. Alright, so pull all of that, and I'm going to draw a little squiggly line to separate this. Pull all of that to put here. We're going to kind of have to squeeze things in. X cubed, 3x squared, and 6x squared is 9x squared, 27x plus 27. I don't like writing it below like that, but I kind of had to. Alright, so now let's move everything to one side. Subtract x cubed, subtract 27 on both sides. Cancel on the left, and it cancels on the right. So you have 0 equals 9x squared plus 27x. Bless you. What do I do now? Take out your greatest common factor. 9x squared and 27x, what can I divide out of that? 9 and a what? X. So 9x squared divided by 9x leaves me with x. 27x divided by 9x is 3. What do you do with those two things? I just unmultiplied. I don't want to go back and multiply again. 9x equals 0, and x plus 3 equals 0. Set both factors equal to 0. Right here, divide by 9, and x equals 0. Over here, subtract 3 from both sides, and x equals negative 3. The bad news is you have to check them. It'll be quick though. When I'm checking that one, the first one, 0, I have the cube root of 0 cubed plus 27 equals 0 plus 3. Well, 0 cubed is just 0. So that leaves me with the cube root of 27. What's the cube root of 27? 3. And the right side is 3, because 0 plus 3 is 3, so that one works. So 0 is good. What? Okay, so let's check the second one. I have the cube root of negative 3 cubed plus 27 equals negative 3 plus 3. What's negative 3 cubed? Negative 27 plus 27. What's negative 27 plus 27?
0.
So I have the cube root of 0, which is 0. What's negative 3 plus 3? 0. If I bring that down, does 0 equal 0? Yes. So Royce, to answer your question, yes, you will get sometimes two answers that are both correct. You gotta check it. If it says to check, you gotta check. Okay? So that would be H.
Do you want us to start talking about answers on the
Yes, ma'am.
All right. Number 5. Number 5 says I have f of x equals 3x to the 1/3 minus 1. And then I have g of x. Actually, let me put this in a different color. G of x equals x plus 1 over 3 cubed. And the problem says determine whether the functions are inverses. To determine if they are inverses, and on the assignment a lot of you did not do this, so you got your problems wrong. To determine if they are inverses, you have to plug them in. You can't just graph and look at the graph and eyeball it. You have to plug one into the other. So I have f of g of x. So I'm plugging the whole g function into the x part of the f function. So right here, I'm going to have, every time I write the g function, it's in red, the blue will be the f. So 3 times the whole thing of x plus 1 over 3 cubed, and that's all raised to the 1/3 minus 1. Does everybody see where everything came from? The red is in place of x. So now to simplify this, 3 to the 1/3 cancels. So I have 3 times x plus 1 over 3 minus 1. Now what? Multiply, so 3 on top, 3 on bottom, they cancel. And I have x plus 1 minus 1. Plus 1 minus 1 leaves me with x. So f of g of x is x. So that one checks. You have to check it the other direction now. G of f of x. So now, in place of x, I'm putting the f function, 3x to the 1/3 minus 1, plus 1 over 3 cubed. Work inside your parentheses first. So inside right here, I can't do anything inside the blue, but then -1 plus 1 cancels. And I have 3x to the 1/3 over 3 all cubed. Still, work inside your parentheses. What do you get? The 3's cancel. X to the 1/3 cubed, which is x, because the 1/3 and the cube cancel. So g of f of x is x. It checks out. So, are they inverses? Yes. So that would be B. Okay? Moving along. Number 6. Let G, and I'm not going to write out the whole problem, but I'm going to use some shorthand for it. Let G be a reflection on the y-axis, followed by a translation 4 units down of this. F of x equals 3 times the cube root of x plus 2. Okay? These are y'all's favorite. Okay, so first you have to do the reflection on the y. So my h of x, the reflection on the y, is that going to be a negative inside or outside? Inside. So f of negative x. Change every x to negative x. So 3 cube root of negative x plus 2. And I really didn't even need the parentheses that time. So that part's done. Now g of x, because it says followed by. Down 4. Is that going to be inside or outside? Outside. So it's the h of x plus or minus? Minus 4. So I'm going to write that whole red function right there and then minus 4. So I've got 3 cube root of negative x plus 2. That's all underneath, and then a minus 4 on the end. Do you see your answer? It looks like it's going to be J. Okay? Number 7. Let G be a horizontal shrink by a factor of 4/5, followed by a translation 5 units left of the graph of f of x equals the square root of 20x. If you got this wrong, I can almost guarantee you I can show you exactly where you went wrong. So first, horizontal shrink 4/5. Is that going to be inside or outside? Do you flip or not flip? You flip. Anything on the inside, you have to flip. So it's f of 5/4x. Change every x to 5/4x. So the square root of 20 times 5/4x. Simplify that. 20 times 5/4 ends up being 25. So there's my h of x. First place you could have gotten it wrong is without flipping that. Then we have left 5. Is that inside or outside? Plus or minus? So g of x is going to be h of x plus 5. Which means, here's where the second place you would have messed up probably. You have 25, and then in parentheses, x plus 5. You have to put that in parentheses, which means you have to distribute. 25 times x is 25x, and 25 times 5 is 125. That right there is probably the main spot where most of you missed it. So that answer should be C, and y'all probably put B. How many of you put B? Yep. All right. Moving on. Number 8. Let G be a translation 1 unit down and 1 unit left, followed by a reflection on the x. And our function is f of x equals -3/10 times the 4th root of x minus 11/10. So first, we need to move down 1, left 1. So when our h of x, tell me what I'm going to write. F of what? Negative, no, that would be a flip. I can't do a flip first. So for my minus, or for my down 1, that's going to be a -1 on the end. For my left 1, that's going to be an x plus 1 on the inside. So right there, every x I'm changing to x plus 1. On the end, I'm putting a -1. So -3/10, 4th root of x plus 1, and then -1 on the end. That part's done. Now, g of x is the reflection over the x. And you said a while ago negative on the outside, which is right. I just couldn't do it yet. So negative times the whole thing. Negative, put in parentheses, -3/10 times the 4th root of x plus 1 minus 1. When you distribute that negative, Negative times negative 3 over 10 is positive 3 over 10, fourth root of x plus 1. That's all one thing right there. And then negative times negative 1 is positive 1, and we've messed up.
What?
Look right here.
The negative 11 over 10.
Yep. I did not put the negative 11 over 10 right there, which means this should be negative 21 over 10, and that's going to be positive 21 over 10. Sorry about that. All right, what's our answer there? Jay? Sorry for my mess up.
And nobody knows the way
That's the bad thing. Y'all should have noticed it. Call me out. 9. Let G be a vertical stretch by a factor of 2, followed by a translation 5 units left of the graph of f of x equals the square root of x plus 3. So, first, vertical stretch of 2, inside or outside?
It's outside.
Outside. Flip or not flip? No. 2 times f of x. So just multiply 2 times the whole thing. 2 square root of x plus 3. Distribute, which gives me 2 square root of x plus what? 6. Very good. Now, do your g of x, which is your left 5. Is that inside or outside? Inside. Plus or minus? Plus. H of x plus 5. So I have 2 square root of x plus 5 plus 6. What letter is that?
It's
No. It's B.
okay.
Because the 2's on the outside, not the inside. All right, number 10. Number 10 is 6 to the 7th over 15 to the 7th, all to the negative 1/7. 6 and 15 are not the same base, but they have the same exponent, right? So we're going to put them together, 6 over 15, all to the 7th, and then that's all to the negative 1/7. 7 to the negative 1/7, what happens there? They cancel, but you're left with negative 1. So 6 over 15 to the negative 1. Now what?
Don't you have to put it?
Negative 6 over. Right?
No. Negative exponent makes you do what?
Put it all over negative 4.
Flip it. So you have 15 over 6. Does 15 over 6 reduce? Okay. 15 over 6. 5 over 2. And if you're saying it doesn't reduce and you're looking at your paper, there's not a 15 over 6 as your answers. So 5 over 2 is F. All right, 2 minutes. We can do number 11. Number 11, solve y equals f of x for x. And the output is negative 7. So here we go. F of x equals x plus 2 squared minus 14. That means I have y equals x plus 2 squared minus 14. I don't have to change anything, I just have to solve for x. So I'm going to add 14 to both sides. So I have y plus 14 equals x plus 2 squared. Now what? Get x by itself. What do? Take the square root. And that's going to cancel that square on the right side. So now I have the square root of y plus 14. But anytime you take the square root, you have to put plus or minus in front. And on the right side, I have x plus 2. Now what?
You switch the x over.
Subtract 2 from both sides. The y plus 14 is under the square root, so you leave it under the square root, y plus 14. That minus 2 is going to go on the end. Now look at your answer choices. No, it just says solve for x. It doesn't say switch anything. Look at your answer choices. They're all x equals. So which one is x equals plus or minus the square root of y plus 14 minus 2? C is the only one, so we don't even have to plug it in and find what the output is, because C is the only one that has the right function. Okay? That was number 11. All right. Number 12 is f of x equals negative x cubed plus 2. And it says determine whether the inverse of f is a function, then find the inverse. You can put it in your calculator and graph. So we're going to delete what's there. Plug it into the graph, and we have a calculator that doesn't want to cooperate. There we go. Negative x cubed plus 2. So if I graph that, how do you determine if it is if the inverse is a function or not? What kind of test do you do? Horizontal line test. If you do a horizontal line test on this original graph, it passes everywhere, right? So then the inverse is a function. So that's going to be a yes, which is going to knock us down to a couple of them. Then let's go ahead and find the inverse. So we have y equals negative x cubed plus 2. So then we are going to subtract 2 from both sides. And we have y minus 2 equals negative x cubed. Divide by negative 1. So we get negative y plus 2 equals x cubed. And then what do I do? Take the cube root of both sides. On the right side, the cube root and the cube cancel. And I get the cube root of negative y plus 2 equals x. Flip that over, and you have x equals the cube root of negative y plus 2. Now, I'm writing the inverse, so what do I have to do next? Switch the variables. Y equals the cube root of negative x plus 2, and then f inverse of x equals the cube root of negative x plus 2. So we already said yes, the inverse is a function. So that knocks us down to G and J. Which one works? G. G is the only one that has the radical all the way across the 2. Now, H also has the radical all the way across the 2. It does say no on H, but it also has a plus or minus. You can't have a plus or minus with a cube root. So that takes that out. So G is the one we're looking at there. All right. Number 13. You have the square root of 8 over the square root of 648. What would you do first? Square root on top and bottom. I would take, because you don't have an equal sign, so you can't just square both of them, but put them under the same square root. So 8 over 648. Now let's see if we can reduce that fraction. So if I take 8 and divide by 648, I get 1 over 81. So now I have the square root of 1 over 81, which is what? What's the square root of 1? 1. Square root of 81? 9. Which is A. All right, then let's look at 14. The cube root of 216. It says do this using a calculator. So actually, I'm going to go ahead and write down 14 and 15 because they're both using a calculator. 61 to the negative 7 over 8. We can just plug them both in at the same time. So the first one is the cube root of 216, and that gives us 6, which is H. The next one is 61 to the negative 7 over 8, which gives us this big O long number to 2 decimals. 0.027 gives me 0.03. So this one is 0.03. This one was 6. So that's H, and this one is A. Question on those? All right. Number 16, right in simplest form. I have the cube root of 64 over 9. 64 over 9 does not reduce. So I'm going to have to do a factor tree with 9. And it's 3 times 3. So if I were to split this up and do the cube root of 64 over the cube root of 9. I need groups of 3 for a cube root, right? For it to cancel. I only have 2 things now. I need 1 more. What do I need 1 more of? I need another 3 out there. So I'm going to multiply the top and the bottom by the cube root of 3. So then on the top, right now I'm going to leave it as 64 times 3. And on the bottom, I have the cube root of 3 cubed. Does everybody understand where the 3 cubed came from? So I've got 1, 2, 3. All right, so the cube root and the cube cancel. And I have the cube root of 64 times 3 over 3. Do you have an answer choice that looks like that? No. So let's see if 64 is a perfect cube. Whoops. And it is. So if 64 is a perfect cube, I could rewrite that as the cube root of 64 and then the cube root of 3 on the top. Right? Cube root of 64 we saw was 4. And then times the cube root of 3 over 3. And that is G. Now, just in case that didn't work out and you had your 64 times 3 here, you can take a factor tree to 64. 64 is 2 times 32, which is, no. Is that right? Yeah. And 32 is 2 times 16, which is 2 times, which is 2 times 4, and that's 2 times 2. So if we're looking at groups of 3, there's a group of 3 right there, and there's a group of 3 right there. So this could be rewritten as the cube root of 2 cubed, cube root of 2 cubed, and then your cube root of 3, which would give you your 2, which is 4. So you can do it like that, or you can put it in the calculator and check and see if it works out. Either one is fine. Last one, 17. We have 7 over 5 minus the square root of 5. How do I work this? Can't have a radical on the bottom. What do I multiply by? The conjugate, 5 plus the square root of 5. So multiplying by 5 plus the square root of 5 on the top and the bottom, the top, I have 7 times 5 plus the square root of 5. The bottom, you have to box. So 5 plus the square root of 5. 5 minus, no, sorry. Yeah, that's right. 5 plus square, plus and 5 minus. Box that. 5 times 5? 25. 5 times square root is 5 square root 5. And then this one is negative 5 square root 5. This one is negative. Square root of 5 times square root of 5 would be square root of 25. What's the square root of 25? Now, if you look right here, I've got negative 5 square root of 5 and positive 5 square root of 5. They cancel out and give me 25 minus 5. Distribute the top. What's 7 times 35? Sorry, what's 7 times 5? 35. Plus 7 square roots of 5, and then 25 minus 5 is 20, which is A. And there we go.